Hi everyone, right? Hi everyone, good evening all of you. How are you all guys? Audio both are clear. How are you? Audio both are clear everyone? Just check it somebody. Right, so now we'll be continuing our discussion on this all formula revision, right? All formula revision of which one? This highway engineering, right? All formula revision of this highway engineering we are going to see now, right? Yes, na? All formula revision of this highway engineering we'll see, right? So we'll be continuing our discussion on this, you can say, right? So yesterday what we were discussing, if you just remember? Yesterday what we were discussing, if you just remember? Yesterday we were discussing about this rigid payment, na? Yes, yesterday we were discussing about this rigid payment, and not all of you. Yes, yesterday we were discussing about this rigid payment, you can say, right? Rigid payment, you can say, yes, na? Right. So now we'll be continuing our discussion on this rigid payment, right? If you just observe, right? So all of you, welcome to Unacademy. Let's crack it, right? Everyone ready to crack? Get ready to crack, all of you. This is my profile, you can follow me at which, and this is my referral code you have to use, RP Civil Live. These are all the plus subjects I'll be taking in Unacademy. And all of you, January 30th and 31st, right? Tomorrow and day after tomorrow, there is a 20% offer, right? There is a 20% offer you are having, right? There is a 20% offer you are having, right? Means whenever you are using the referral code RP Civil, whenever you are using the referral code RP Civil Live, you will be getting which one? This is 20% discount, right? Don't miss this, all of you, right? Don't miss this, all of you. Right, don't miss this, all of you, right? Don't miss this, all of you, right? So inform to all your friends, juniors, those who are willing to subscribe, they will be subscribing within this 30 and 31st, so that they'll be getting 20% discount, and they'll be continuing their journey. Yes, na? So this is iconic subscription benefits. We are having personal coach will be there, personalized test analysis will be done, and study planning is also given to you. All these things, right? Yes, Santosh, hi, hello. And bi-weekly reviews, right? All these advantages you will be having if you are taking this iconic subscription. It's not. And everyone, don't miss this mock test, right? Last test will be there today, tomorrow, right? Tomorrow will be the last mock test on which one? This GATE, you can say, right? Tomorrow will be the last mock test on this GATE, you can say, right? Last mock test on this GATE, you can say, that you try to which one? That you try to attend, right? Because how much preparation you are doing, that much important the mock tests are, okay? Don't miss them, right? And this combat event also, January 30th at 11 a.m. you'll be having this combat event also, right? What is it, combat event? If you just observe, whenever you are attending this test, the top 100 participants will be getting which one? This exciting prizes from here, right? So if you are financially weaker, let us say, right? If you are financially weaker, then you are having some subject knowledge and you wanted to enhance your knowledge, then you attend this combat event. Every week these combat tests are going on, right? Every week these combat tests are going on, if you just observe, right? So don't miss this combat test, all of you, right? Don't miss this combat test, all of you, right? So attend this combat test, and also what you will do, you get these exciting prizes and 100% free scholarship also you can get it, okay? Just don't leave this. And now these are the new batches we are having, right? Ascend batches, yes, na? These are the new batches we are having, right? Ascend batches and evolve batches, you can say, if you just observe. And these are the foundation batches also you are having, if you just say, right? For GATE and ESE, right? So these are started on which one? These are started on which one? So RP Civil Live is the code you have to use whenever you are subscribing for the plus and iconic courses, okay? Like that. So now foundation batches and all these batches we are having, right? Like that, yes, na? Right, shall we enter into this, all of you? So we'll just enter on to our discussion on this formula revision. So which part we are discussing, we just remember yesterday? Which part we are discussing, we just remember yesterday? Right, this is your which one? This 289, right? What is that 289? You can say that joints in the rigid payment, just we have seen, na? Yes, this joints in the rigid payment, right? Joints in the rigid payment is the these are the different types of these joints we have seen, right? So what are the list of joints available we have seen, but what is that you can say, but what is that you can say, if you just observe, but what is that you can say, but we did not see, right? But we did not see what are the different conditions corresponding to this, we did not see, right? How to design these joints and everything we did not see, right? Yes, I'll be sharing it, right? I'll be sharing this, don't worry Santosh, I'll be just sharing this once this is over, right? Tomorrow it will be over, tomorrow will be the last class, mostly after tomorrow I'll be sharing these notes in my community, okay? You can just follow my profile and you can press that community tab and you can get it in that. Okay, I'll be just sharing it in that, don't worry, right? That is your 289 and this is your lesson 30, part 30 and 29th January, you can say. Okay, right. So it is 31, sorry, lesson 31, not 30. 289 means this is your 290, we can say. What is that 290 if you just observe? What is that 290 if you just observe? Here it is 290 means what? 290 means what? So these are the different types of these joints you are having, you can say. If you just consider these diagrams now. If you just consider this, what is that you can say? This is your pavement panel, right? This is your pavement panel. These are your pavement panels, you can say, along the length if you just observe it. And here also you are having some gap, let us say, and this is a continuation, right? Have you observed this kind of pavement panel? Right now if we just consider it, these are your small chota panels inside. Now tell me, these joints are provided in which direction? These joints are provided in the length direction. Because these joints are provided in the length direction, right? These longitudinal joints, what they are doing? These longitudinal joints, they are providing, which one of you? These longitudinal joints are providing, these longitudinal joints are dividing the width into different formats, isn't it? Dividing the width into different formats, you can say, right? Dividing the width into these different formats, you can say, if you just observe, right? Like that, isn't it? Right. Now, if you just observe, what is this joint with a gap? What is this joint with gap, all of you, if you just observe? That joint with gap, if you just say, right? Joint with gap, if you just observe, joint with gap, if you just observe, what is that joint with gap, if you just say? That joint with gap is your expansion joint, if you consider, right? What is that expansion joint is doing? What is the expansion joint is doing, if you just observe? That expansion joint is dividing the beam into two parts, now, if you just observe. It is dividing the beam along the length. Longitudinal joint is dividing the beam in the width, longitudinal joint is dividing the pavement panel in the width direction, and this expansion joint is dividing the panel into which one? This width direction, because right, like that, is not? So now along with this, these are some other joints also, chota wala joints also we are having, right, between the expansion joints, you can say, it's not? So if you just try to write one after the other, this is your which one? This one transverse joints. Right, transverse joints, right? Transverse joints we are having, right? Like that, which is most work-life balanced job, right? Every job, it is depending upon you only, right? The Danish, it is depending upon you only. You have to balance whatever the work you are doing. You have to maintain balance between the work and the life, right? You should not fully involved in the job and neglecting the family. Don't do like that, okay? It is depending upon you only, balancing both, right? And convincing your boss that boss, I need to take care of my family and all these things, right? You have to do on your own, right? And among this transverse or this lateral joints, right? Among this transverse or this lateral joints with the gap, these are present, then this is called as your expansion joint. This joint is called as your expansion joint, and without a gap, what is this joint called as, you can say? That is called as your this contraction joint, you can say, right? That is called as your contraction joint, right? And what is this joint, you can say, if you just observe these joints, what are these joints? Along the length they are present, na? So these are your longitudinal joints, right? These are your longitudinal joints, or you can also call them as which one? This warping joints. So means the main purpose of this joints is only to take care of warping, nothing else. It's not. And now, sometimes if you just observe, we will be providing some reinforcement bars on this, right? Where we will be providing reinforcement bars? If you just observe, we will be providing some reinforcement bars on this transverse joints. Tell me, what are the reinforcement bars provided on this transverse or lateral joints? If you just observe, what is the name of this reinforcement bars provided on this transverse or lateral joints, all of you? And we are providing some other reinforcement bars on which one? This longitudinal joints, right? Now tell me, anyone, by the time I am drawing this, tell me the names of these bars provided. On the longitudinal joint, what is the name of the bar? On the transverse joint, what is the name of this bar, all of you? What are these bars if you just observe? These bars provided on the longitudinal joint are called as your tie bars. Right? The bars which are provided, right? The bars which are provided on the transverse joints are called as which one? This is dowel bars, you can say, right? These are your dowel bars if you just observe. Which bar? Which are provided on the transverse joints if you just say. These are your dowel bars, right? So now whenever you are considering a vehicle, right? Whenever you are considering a vehicle, right? 1 second, that vehicle will be moving like this now. Yes, this is the vehicle, let us say, right? It is the direction of movement of this vehicle. And now along the length of this vehicle, this is your LX length of the panel. Along the width of this vehicle, it is width of this panel LY, you can say, right? And so what is that you can say? LX is the length of this each and every small panel. Can we say that the length of each and every small panel is nothing but length of each and every small panel is nothing but the distance between which one of you? It is the distance between the distance between the contraction joints, you can say it now. It is the distance between the contraction joints, you can say it or not? Yes, it is the distance between the contraction joints, right? Isn't it? Distance between the contraction joints, you can say if you just observe, right? Isn't it? Distance between the contraction joints if you just observe, right? Like that. And now what is the distance between the expansion joints, you can say that a distance or spacing between the expansion joints is which one? This LE, we can say, right? LE. And what is the gap at the expansion joint? You can say that gap at that expansion joint is capital delta, you can say, right? This is a delta is a gap at expansion joint. Spacing between the expansion joints is your LE, right? Like that. Is a clear? Is that clear? Once this diagram is noted, tell me everyone, all of you. Once it is done, tell me everyone. Once it is done, tie bar and dowel bar. Yeah, here tie bar, right? What is that you can say? The tie bar is located on this which one? This longitudinal joints, right? Tie bar is located on this longitudinal joint, right? Right. Tie bar is located on this longitudinal joint, right? Tie bar is located on this longitudinal joint, you can say. And this dowel bars are located on which one? Dowel bars are located on which one, you can say? Dowel bars are located on this transverse joints, right? What are the two transverse joints, you can say? The two transverse joints are which one if you just observe? One is your expansion joint and other one is your contraction joint. Na? One is your expansion joint and other one is your contraction joint. And all of yes, one is your expansion joint and other one is your contraction joint if you just observe. Is that clear everyone? Is that clear everyone? Is that clear Santosh? Yes, na? Right. So this is about your joints, right? This is about your joints, right? Which joint you can say if you just observe? Expansion joint, contraction joints, longitudinal joints, and all these types of joints, right? Spacing between the expansion joints, right? Spacing between the expansion joints are which one? Spacing between the expansion joints are which one? Spacing between the expansion joints are which one? Spacing between the expansion joints is what? You can say it is LE. Spacing between the contraction joints is your LX, and spacing between the longitudinal joints. Spacing between the longitudinal joints. What is it? LY na? LY is the width of the panel, right? LY is the width of the panel, right? LY is the width of the panel, or you can also say it as the distance between the longitudinal joints, you can say. Yes, na? Like that you can say if you just observe, right? Once it is done, tell me. I'll try to enter into this expansion joints and write the expression for this expansion joints. Yes, Santosh, very good. This is your expansion joints if you just observe. What is that condition of this expansion joints, you can say, Santosh? What is the condition of this expansion joint, you can say? Expansion joint is to allow the expansion of this panel. Expansion joint is to take care of which one? It is to take care of what, right? This point is very, very important, right? It is to take care of what, right? It is to take care of expansion. Why this expansion is occurred? When that expansion is occurred, if you just observe, expansion will occur because of this rise in temperature, na? Why this expansion will occur? Whenever there is a rise in temperature or fall in temperature, all of you. To take care of the expansion which occurs, right? Which occurs, right? which occurs what, right? Which occurs due to rise in temperature, right? Yes, rise in temperature, right? Due to this rise in temperature, right? Due to this rise in temperature, rise in temperature with respect to which temperature? Construction temperature. Rise in temperature with respect to which one? This construction temperature, right? Rise in temperature with respect to this construction temperature, right? Rise in temperature with respect to this construction temperature, right? If you just observe, right? Rise in temperature with respect to this construction temperature, right? Now tell me, whenever you are considering this point, that a temperature effect used in that expansion joint will be, what is that you can say? It is the rise in temperature. How much rise has occurred with respect to the construction temperature only we have to consider, if you just observe, right? Like that, isn't it? Now if you just say, right, these are your joints now. This is let us say left panel, and this is your middle panel, you can say, and this is your which one? This right side panel, if you just observe it like that. And what is this gap? Let us say this gap comes to be this delta. This gap comes to be this delta. And what is this? That spacing between the expansion joints is your LA, right? Now tell me, what is the expression for these two, if you just observe? What is the relation between this LE and spacing between the expansion joints and the gap at expansion joints, all of you? What is the relation, you can say, if you just observe, right? Here we do not allow this full gap, right? We'll be filling this gap, right? How much gap will be filling? Half of this gap will be filling, right? Out of this delta, this delta by 2 portion is filled. Only the remaining delta by 2 portion is allowed to expand freely. Whenever this delta by 2 portion is filled, so remaining delta by 2 means right side delta by 4 and this left side delta by 4 only na. So total, so this panel, so this side delta by 4 it will expand, and right side delta by 4 it will expand, like that. Yes, na? Right? Is it clear? That filler material we are providing at the center, right? That filler material we are providing at the center, right? What is that filler material will do, if you just observe? Why we are providing this filler material, if you just say? Because even though we are telling it as expansion joint, will it only expand practically? No. During the rise in temperature, this expansion will occur, that gap will be filled. During the rise in temperature, this expansion will occur, gap will be filled. But during the fall in temperature, they will be contracting and the gap will be increased, and whenever a vehicle is traveling on this, it is unable to travel. Na? Yes or no? It is unable to travel, right? This is your H thickness, like that. So that is the reason only that a half of this delta we will allow free expansion, remaining delta by 2 we don't allow. Okay, is that clear all of you? Is it clear all of you now? Yes, now. So therefore, what is that you can say? What is the relation? You can say that delta by 2 is equal to, what is that you can say? Delta by 2 is equal to, right? What is that? This delta by 4 for this LE by 2, right? This delta by 2 is equal to that LE, right? What is the delta by 2? You can say LE into alpha delta T. LE into this alpha delta T, right? What is that alpha? Coefficient of thermal expansion, right? What is the delta gap? What is the LE spacing, right? So delta T is the rise in temperature, alpha is the coefficient of thermal expansion, and LE is the spacing between the expansion joints, right? Now tell me, as per, what is that you can say this? As per this IRC, what is that you can say? This gap at expansion joints, right? What is that gap at expansion joints, you can say? Gap at expansion joints, that delta should not be greater than how much? This 2.5 centimeters, na? That delta should not be greater than this 2.5 centimeters, right? If it is greater than 2.5 centimeters, restricted to 2.5 centimeter, right? And what is that you can say? Spacing of expansion joints, right? One expansion joint to other expansion joint. What is that you can say? Spacing of this expansion joints, right? Spacing of this expansion joints, right? What is that you can say? That LE should not be greater than, right? Should not be greater than which one? This 140 meters, you can say, right? Should not be greater than this 140 meters, you can say, right? Like that. Is that clear, everyone? This is about this is about which one? This expansion joint, right? This is about this expansion joint, right? Yes, now is that clear? This is the story of your expansion joint. You can see if you just observe, right? Like that. Shall I move to the next one? Yes, I'll be moving on to the next one, right? 291. This is your 292, right? What is that? 292? Contraction joints. What is that contraction joints, you can say? What is it? Contraction joints, you can say. What is it? Contraction joints, you can say. Contraction joints are to take care of which one? This contraction. When that contraction will occur? Whenever there is a rise in temperature or whenever there is a fall in temperature. Whenever there is a fall in temperature, that contraction will occur, right? So contraction joints, these are provided to take care of what? Contraction joints provided to take care of which one? This is contraction, right? When this contraction occurs, you can say contraction, right? Which occurs due to what? Which occurs due to which one? Which occurs due to which one? This fall in temperature with respect to what? Construction temperature only. Fall in temperature with respect to this construction temperature only. Rise in temperature with respect to construction temperature, expansion will occur. That will be taken care by means of which one? This expansion joint, right? Contraction joints will be taking care of which one? This contraction, which is occurring due to which one? This fall in temperature with respect to the construction temperature. Yes, na? Right. Now here, if you just observe this, there are two conditions we are having, right? Whenever it is without dowel bars, right? If the dowel bars are not provided, if the dowel bars are not provided on this contraction joints, right? What is that? You can say without dowel bars means it is the plain cement concrete, or it is which one? It is obviously that plain cement concrete. It is a plain cement concrete, right? It is a plain cement concrete, you can say it na? Yes, plain cement concrete, right? CC is nothing but your plain cement concrete, right? No dowel bars are provided. When dowel bars are not provided, who will be taking care of this contraction effect? Dowel bars only, no? Dowel bars only, no? Dowel bars are not there means concrete is only supposed to take care, right? Concrete is only supposed to take care of this, right? Concrete is only supposed to take care of this, right? Like that is a clear, right? So what is that? You can see if you just observe that spacing of this contraction joints. Spacing of this contraction joints, right? What is the spacing of this contraction joints? LX is the spacing, na? That LX will be the spacing of contraction joints. If you just observe, what is that? You can say here in this diagram, this is one contraction joint and this is another contraction joint, right? Between these two, what is the spacing you are having? That is your LX, na? LX is the spacing of this contraction joints or length of the panel, right? Anyone you can say. Oh, if you just observe, right? Isn't it? What is that? You can say that 2 times that sigma. What is that? You can say 2 times that sigma CT divided by which one? This gamma F. 2 times that is sigma CT divided by this gamma F, right? Gamma C into F, right? Gamma C into F, right? What is the sigma CT if you just observe? It is nothing but your permissible. What is that? You can say it is nothing but your permissible stress in which one? This concrete in tension. Yes, na? Permissible stress in which one? This concrete in tension. Whenever you are that sigma symbol, it is used for permissible stress. C means concrete, T means tension, right? Permissible stress in concrete in tension, right? What is that? Gamma C, you can say gamma C is nothing but your density of concrete, right? Gamma C is nothing but your density of this concrete, right? Whatever the concrete you have used, that is the density, right? Yes, na? And what is that? F, you can say it is the coefficient of friction, right? Coefficient of friction between what? Slab. Which slab? Pavement slab, na? Rigid pavement slab, na? Rigid pavement slab and the soil, right? Rigid pavement slab and the bottom soil, right? Whenever your panel is subjected to contraction like this, who will be obstructing this contraction? That friction offered by this soil only will be restricting this contraction or not? Yes, absolutely. That is only restricting this contraction, you can say. It's not like that. So now, what else we are having? If you just observe, this is your without dowel bars, right? If dowel bars are not there, right? If dowel bars are not there, right? If dowel bars are not there, okay? If dowel bars are not there, right? If dowel bars are not there, This is the thing we have to provide, right? Now suppose if double bars are present and this should not be greater than, right, and this should not be greater than how much you can say, if you just observe, and this should not be greater than how much you can say, this should not be greater than which one, this is 4.5 meters, right? If it comes to be greater than 4.5 meters, restrict it to 4.5 meters, okay, restrict it to that 4.5 meters, right? Is it clear? Right. Now with the dowel bars, with the dowel bars, if you just observe, with the dowel bars, if you just observe, whenever that dowel bars are present, what is the meaning of this dowel bars? Dowel bars are nothing but your steel reinforcement bars only, no, provided at the joints. Whenever these dowel bars are present, who will be taking care of that? Steel will take care, or the dowel bars only will take care, na? Then what is the spacing of this contraction joints, LX, you can say? 2 times that sigma st into what is the, you can say, that AST, area of this steel in tension, divided by which one? This divided by what is the, you can say, if you just observe, divided by what is the, you can say, if you just observe, what is the, you can say, HFC, right? Gamma C HFC, right? Gamma C into HFC, right? Gamma C into which one? This is HFC, you can say, if you just observe, right? Like that. So gamma C, we know what is the H, you can say, H is nothing but your thickness of this CC slab, na? H is nothing but your which one? This is thickness of this CC slab, right? Cement concrete slab thickness is H, you can say. And what is the sigma ST, if you just observe? Sigma is the symbol we are using for permissible stress. S is the steel, T is the tension, right? Right. This is your F gammas, right? Gamma C H into gamma C into H into F, right? F is nothing but your same coefficient of friction between which one? Coefficient of friction between which one out of you? It is a coefficient of friction between, what is the, you can say? It is a coefficient of friction between which one? Ly also comes into picture, right? Ly comes into picture here or not? This will not come. Okay, sigma st is nothing but your permissible stress in what? It is permissible stress in steel in tension. Permissible stress in steel in tension. Permissible stress in steel in tension, if you just observe, right, like that. Is not permissible stress in steel in tension, if you just say, right? So now what is the, you can say, if you just observe, this is with the dowel bars you are getting, that is without dowel bars, this is with the dowel bars you are getting, if you just observe, right, like that. So what is that? 2 sigma st into AST. AST is nothing but your which one? This area of steel in tension, na? Area of steel in tension, right? Area of steel in tension, if you just observe, right, like that, isn't it? Total area of this steel required, right? So this is about the design of your contraction joints, you can say 292. Now 293. What is the, you can say, that longitudinal joints, na? These are your longitudinal joints, right? What is the purpose of this longitudinal joints? These are mainly to take care of what? These are mainly to take care of which one of you? These are mainly to take care of which one? This warping. In which direction? Mainly to take care of this warping in width direction. So warping in length will be taken care by this contraction and expansion joint. They will be reducing the length, right? They will be reducing the, yes, alok, correct, right, tie bar. So mainly take care of this warping in the width direction, right? So when we have to provide, if width of pavement, right? If width of pavement, right? If width of this pavement, right? If width of pavement is greater than this 4.5 meters, right? Longitudinal joints are provided, right? Longitudinal joints are which one? This longitudinal joints are provided, you can say, right? Longitudinal joints are provided, right? Longitudinal joints are provided, right? So that means, suppose if the width of the pavement is which one? This let us say width of the pavement is 3.5 meters, 3.75 meters, right? Whenever it is a 3.75 meters, what is it, you can say? Whenever it is a 3.75 meters, what is it, you can say? 3.75 meters is a single lane na? So it is lesser than 4.5 meters, means do you require any longitudinal joint or you don't require any longitudinal joint there? You don't require any longitudinal joint, you can say, right? You don't require any longitudinal joint, you can say, right? If you just suppose if it is a 2 lane, suppose if it is a 2 lane, 2 lane means 7 meter na. Whenever it is a 7 meter, compulsorily we have to provide one joint, right? Compulsorily we have to provide one joint, right? Where we have to provide? It is better we provide at 4.5 meter and the remaining 2.5 meter. No, it is better you provide it which one? This is center 3.5 meter. Suppose if it is a 3 lane, then 10.5 meters. Then if you provide only one joint na, 10.5 by, right, 10.5 by 2, how much it will become? Right, 10.5 by 2, how much it will become? 5.25, right? Again it is becoming more than 4.5, so therefore it is better you provide two joints for 3 lane. 2 joints means it is dividing into 3 panels, right? Whenever you are providing this 2 joints na, 3 lane road is there, 1 joint and 2 joint if you provide, now what it will become? So this will become this 3.5, this will become this 3.5, this will become this 3.5, you can say, right, like that, yes na? So can we say it is 1 joint per this 1 joint per which one? 1 joint per which one? At 1 joint per which one? This is 3.5 meters width na. 1 joint per this 3.5 meter width na. 1 joint per this 3.5 meters width, you can say, if you just observe 1 joint per this 3.5 meter width, right? Like that. Is that clear? Is that clear? Yes na? 1 joint per 3.5 meter width, right? Suppose if a 3 lane road is there, so from here let us say this is a 3 lane road, from here to 3.5 meter 1 joint, from here to 3.5 meter 1 joint, again one more 3.5 end. So 3 lanes are there, 2 joints, 4 lanes are there, 3 joints, 2 lane is there, 1 joint, right? So can we say it is number of longitudinal joints is equal to, can we say that from here, can we say that, right, number of longitudinal joints is equal to how much? That number of longitudinal joints is equal to how much, you can say? That number of lanes minus 1, can we say? Number of lanes minus 1, can we say? Number of lanes minus 1, isn't it? 2 lane 1 joint, 3 lane 2 joints, right? 3 lane 2 joints, 4 lane 3 joints, right? Like that you are having if you just sub, right? Like that you are having if you just sub, right? These are your longitudinal joints, you can say, right? Whenever you are considering this longitudinal joints, right, what is that you can say? That length of this tie bar, if you just observe, what is that length of this tie bar, you can say? Length of this tie bar, right? Which length? Minimum length of this tie bar, you can say, right? Minimum length of this tie bar, if you just say, right? What is the length of this minimum length of this tie bar, if you just say? What is the minimum length of this tie bar, if you just say, right? That L minimum is equal to, yes, that length of this tie bar is equal to 2 times this development length, right? 2 times this development length, right? 2 times this development length. What is the 2 times this development length? You can say, if you just observe, that is your 5 sigma st divided by this 4 sigma b, or you can also write it as which one? This 5 sigma st by which one? This 4 tau bd. What is that tau bd or sigma b? That is sigma b or tau bd will be equal to which one? This permissible bond stress in steel na. What is that? Permissible bond stress in steel, you can say, right? Permissible bond stress in steel, is not? That is your length of this tie bar, right? That is your length of this tie bar, right? And you tell me what is it a length? Okay, that is your length of this tie bar, if you just observe, right? And what is the second one? You can say that phi is the diameter, na? Phi is the diameter of this tie bar, right? Phi is the diameter, you can say, right? Like that. Is that clear? Phi is the diameter of this tie bar, you can say, right? Now what is that, you can say, length of this, minimum length of this tie bar you are having, right? This is a minimum length of this tie bar you are having, if you just observe, right? Now tell me what is the spacing of this tie bar? How can you get the spacing of this tie bar, if you just observe? What is the spacing of this tie bar, if you just observe? What is the spacing of this tie bar? You can get it, all of you, if you just observe. How can you get this spacing of this tie bar, everyone? Right? What is the spacing of this tie bar, all of you? Right? Spacing of this tie bar, how can you get, everyone? Is it 100 by n? Is it 100 by n, everyone? Whenever you are taking it as this 1 meter, right? Whenever you are taking it as this 1 meter, right? Whenever you are taking it as this 1 meter, whenever you are taking it as 1 meter, if you just subtract 1 meter width, we have to consider, right? 1 meter we have to consider it. Whenever you are considering it as 1 meter, right? What is it? You can say, if you just observe the spacing, the spacing of this tie bar S is equal to, anyone tell me? Anyone tell me what is the spacing of this tie bar, all of you? Anyone tell me what is the spacing of this tie bar, everyone? Is it 100 by n? Okay, not that 100 by n actually, right? Right, 100 by n, right? Not by this 100 by n actually, right? It is, okay, if you just observe how it has come is, I'll just show it. If you just observe, right? So this is your Ly, you can say, right? This is your Ly, you can say, right? This is your Ly, you can say, if you just observe, right? This is your Ly, you can say, right? This is your Ly, if you just observe, right? What is that friction acting? That friction is acting in this direction, that friction is acting in this direction, right? So what is that friction? You can say coefficient of friction into that weight, right? What is the weight? Full panel weight. Now full panel weight means gamma c into Lx into what is that? Ly 1 meter we are considering, right? So Lx is 1 meter, right? Let us say this is your Lx. This is your Lx length of the panel. Now where is that provided? If you just observe, this is your length. Along the length we have to provide now. Longitudinal joint, if you just observe it, along the length Lx is 1 meter. Na? Lx we don't know how much it is. Lx you take it as this 1 meter. And what is the Ly? You can say this is your Ly you are having. Na? This is your Ly, and this is the total width of this pavement, you can say, right? Like that. Now what is that? Lx is 1. Na? Lx you take it as which one? This 1, if you just observe it. Lx you take it as which one? This 1. Lx gamma c into length is 1. And width is how much? You can say that width is how much? You can say that Ly into what is the thickness h, right? So this is friction we are having, right? It is equal to what is that? It is equal to what is that? You can say in one spacing, right? In one spacing, it is your area of this single bar you are having, and in 1 meter spacing, how much it comes to be? If you just observe 1 into a5 by s, na. So what is that? You can say the number of bars are nothing but your a5 by s, right? In one spacing, it is a5. And in n spacing, what is the AST? AST, right? So A5 in 1 meter, what is that? You can say in 1 meter, what is that? You can say AST, na? In 1 meter AST, right? So A5 by S, na? So A5 by S into that sigma ST, you can say, if you just right? What is that? Yes, you can get it now from here. S is equal to that A5 into, right, area of this single bar into that sigma ST divided by which one? This F gamma C Ly into H, na? F gamma C Ly into H you are having, right? This is your spacing you are getting, right? Is it clear now? How to get this spacing of this tie bars? That friction will be equal to that tensile, right? Friction will be equal to that which one, right? Friction will be equal to that tensile strength. Friction will be equal to that tensile strength of which one? This tie bars only, no? Yes, tensile strength of this tie bars is only the friction, you can say, if you just observe, right? Like that. From that you are getting it, right? From that you are getting it if you just observe, right? Yes, na? Right, here also what is the, you can say, with the double bars also, with the double bars also, what is the, you can say, that friction, right? Friction, what is that? You can say that F into gamma C into Lx into Ly into that H divided by this 2, it is equal to how much? You can say it is equal to how much? You can say, if you just observe, it is equal to that A5 by S, na? Right? Ly, yeah, A5 into Ly divided by this S, you can say, right? A5 into Ly divided by this S into sigma ST, right? This Ly, that Ly cancel, right? That Ly, this Ly cancel, right? Then what is the Lx? 2 times that sigma ST into this AST, right? 2 times that sigma ST into A5. It is not AST actually speaking, it is A5, we can take it, okay? Area of this single bar, right? What is the A5? If you just observe, A5 is nothing but your area of this single bar, right? It is better we'll use A5 symbol, na? Where is it? Are here? Oh, that entire one has gone. Are okay. With the double bar, what is that? You can say, okay, 1 second, I'll write that. I have deleted by mistake. With the double bars, what is it? With the double bars, you can say that F into gamma C into Lx into that Ly into h divided by 2, that is a friction, equal to sigma st into ast, right? What is that ast? Ly in Lx into that a5 by which one? This, yes. How can you get this Lx into a5? If you just observe it in this direction, right? These are your which one? This Ly into a5 by s or Lx into a5 by s. In one spacing, area of this single bar comes into picture, right? Area of this single bar, right? This is your one spacing, you can say. And what is that? This is your Ly na? And in Ly, what is that, you can say? And in Ly, it is your ast, you can say, right? That ast will be equal to Ly into a5 by s, right? It is Ly into a5 by s, right? Ly into a5 by s. This Ly, that Ly were cancelled. Lx is equal to how much, you can say? Therefore that Lx will be equal to 2 times that is sigma st into that a5 divided by which one? F gamma c hs na, f gamma c hs na, yes, f gamma c hs, you can say, right? This is your Lx if you just observe, right? That is your Lx if you just say, yes na, that is your Lx, right? I think this is missing na, longitudinal joints 292, 293, right? What is it? Longitudinal joints is missing. I'll just write this and close it. These are mainly to take care of which one? This warping only, no? This is missing. Mainly to take care of this warping only, right? And provided if width is greater than, right? If width of this pavement, right? If width is greater than which one? This 4.5 meter, longitudinal joints are provided. Long joints or longitudinal joints are compulsory provided. What is that point I said? Did I write this point? Yes. So what is it, you can say? One joint per which one? Right? One joint per which one? This is 3.5 meters width. The width is 3.5 meters, right? Minimum one joint we have to provide, right? So if it is 2 lane, 2 minus 1, 1 joint, right? If it is 3 lane, 3 minus 1, 2 joints, right? If it is 4 lane, 4 minus 1, 3 joints, like that you can have, right? Like that, isn't it? So this is your 293 and this is your 294, right? What is that given if you just observe? Spacing of this tie bars, right? This is the last point. Spacing of this tie bars, that should not be greater than this 75 centimeters or 750 millimeters center to center. And what is the diameter of this tie bars if you just observe? Diameter of the tie bars, spacing is, yes, diameter of the tie bars, that phi should not be greater than which one? This is 20 millimeters, you can say, like that. So this is about your joints in the rigid pavement, you can say, if you just observe, right? Like that. Okay. So here this is about your rigid pavement, right? And tomorrow we'll see few more things and we'll enter into the traffic, right? Anyone having any doubts? Shall I close the session? Yes, I'll be closing the session. Thank you all of you.